Good morning, and as we continue working with our geometry lessons, we're going to talk about the rigid transformation reflection today. And we want to know how our reflections described mathematically. So my rigid transformations, they are, what are the attributes, right? So the rigid transformation preserves my size, my length, my shape, the line and angle measures of the figure. So rigid, everything remains the same. And then because everything remains the same, I started off with a pre-image, and my transformed new image are congruent. You know, everything is the same, and congruent, of course, means equal. And here I just want to remind everybody that we're going to use this symbol. That means congruent. So instead of writing congruent over and over again, we'll just use the symbol. And the three rigid transformations are a reflection, or are reflections, translations, and rotations. And this is where we're going to focus our attention today, is on reflections. And think about a mirror image is what we're talking about in a reflection. Something that we covered in this last section is being able to distinguish between a pre-image and an image. So what we have here is our pre-image is right here. We have pre-image, this quadrilateral A, B, C, D. That is going to be our pre-image. And then after the transformation, we come over here and we're going to have A prime, B prime, C prime, and D prime. And this is our new image. What we had before, and then what we have after. And then all of the line segments are going to be congruent, and all the angle measures are going to be congruent, as you can see here. C maps to C prime, and if you notice, C has two congruency markers, and C prime has two congruency markers. If you look at segment AB, that maps to A prime, B prime, and it has three congruency markers, and over here, A prime, B prime has three congruency markers. So we're showing that mapping is to show that, you know, those are what corresponds. So as we continue with reflections, in a reflection, all the points of the pre-image are reflected across a line of reflection to reduce the image. How about reproduce the image right there? That's a little bit of a typo, right? A little bit of a typo. And looking at this picture right here, it looks like we have this line right here would be my line of reflection. Just go ahead and write that in here. Line of reflection. And this line of reflection, so as you can see, and that would be line, I'm just going to call it line EG is my line of reflection. It looks like we have A is being reflected over the line of reflection to A prime, B is being reflected over to B prime, and C is being reflected over to C prime. And some of the characteristics that we see, of course, I'm sorry, not of course, but the distance between B and my line of reflection and B prime and my line of reflection are going to be the same length, because it's a mirror image. You know, we've reflected the exact same length across. So the same will go for A to my line of reflection. Its length will equal A prime in my line of reflection. And then, of course, for C, that length is going to be the same as the length to C prime. We'll talk about it more in the future, but in these lines of reflection, what we encounter are the line of reflection is going to be perpendicular to these imaginary segments that we can draw. So those are perpendicular, and thus what we find out, you know, and we'll talk about it more in a couple of units, that these lines are going to be parallel, okay? But the big key here is from A to the line of reflection and A prime to the line of reflection are going to be congruent values. So if we come over here and let's see here, how does this read? It reads triangle ABC maps to triangle A prime, B prime, C prime. So triangle ABC maps to triangle A prime, B prime, C prime. And then we know that A prime, as we said, A to A prime, this segment right here, is going to be perpendicular to line EG. And also, let's see here, B to B prime, segment BP prime, is going to be perpendicular to that same line of reflection. And then finally, C to C prime is going to be perpendicular to our line of reflection. Just some of the characteristics that we can see when we are looking at the reflection and the line of reflection. So looking here in our next example, example number 1, I should be able to examine this and say, okay, here's my line of reflection. It looks like I have ABC is being reflected over that line of reflection to A prime, B prime, C prime. I should know that the segments that are being drawn between A and A prime, that's 90 degrees. B and B prime is 90 degrees. And then if you'll notice, C and C prime are the same location. When your image and your pre-image are the same point, that means that they were on the line of reflection. So looking at that, we can tell that C is on the line of reflection, so when you reflect it, it does not appear to change locations. So there you go. So line segment BB prime is perpendicular to, line B prime is perpendicular to, it's going to be line, and we can go with, there's several different lines we can call it. We can call it line EC, we can call it line CG, we can call it line GE, EG, but I'm just going to say it is perpendicular to line EG. Point L is the blank of the line segment BB prime. Well, let's see here, point L right here. If you remember the characteristics, we know that B to the line of reflection, or BL, is going to be one length, and LB prime is going to be the same length because it's a mirror image. So if we have what appears, if you notice, point L appears to be a midpoint between B and B prime. So point L is the midpoint of the line segment BB prime because it is halfway between B and B prime. And let's see here, LB is blank to LB prime. Well, we just talked about it here that those segments are congruent. And then B prime and A prime are going to be, in this case, I just mentioned it a few minutes ago, they are going to be parallel lines. Okay, that's just another of the attributes. So these are going to be, like to say parallel, or we'll just go ahead and write it in here, parallel. Okay, so there is walking through this example, identifying some of the attributes of a reflection across a line of a image, pre-image, image, and a line of reflection, some of the attributes. So properties of reflection, let's see here, reflections preserve the segment lengths and angle measures, but reflections do not preserve their orientation. Do not preserve orientation. Because if you recall, when we had an image and we translated it, or a reflection, say this is A, B, C, orientation means that A would still remain on top. Orientation, if I move this image around, the orientation remains the same because B is, if you just look at it, B is over here in the bottom left, B is bottom left, A is top, top, C, C. So the shape didn't turn yet, versus here, the orientation changed. So we have, as it reflects and spins around, if you can see that the orientation of point A of my triangle has changed. So that's what they're talking about when they say that in a reflection, the orientation does not stay the same because the locations of B and C would have, if we created this imaginary reflection right here, this line of reflection, we would have had A prime, C prime, B prime, because the locations would have been a mirror image versus maintaining that orientation. And that's what we can see here, that L prime is the farthest left point, or farthest right point, and then on my pre-image, L is the farthest left point. So we did not maintain the orientation. And you can look here because we know that JL corresponds to J prime L prime, and as we go around, we can see where the pieces correspond that their orientation does not remain consistent. So there is my orientation changing because, you know, this segment now is congruent to this segment. So there is a change in my orientation. All right, so reflecting across the x-axis, the x-coordinate will remain the same. Okay, just think about it here. If we talk about reflecting something over the x-axis, here is my x-axis. And if I just reflect something up or down over the x-axis, the x values are going to remain the same. The only thing that's going to change is going to be my y value. If I went from this point down here to this point, my y value went from +5 to -5. So my y values change, but my x values do not. So as I look at the way it is written, I have a reflection across the x-axis of, and they're saying points x and y, will map to my old x and y will map to x negative y. So my x values do not change when I map. According to this, it would be my x values would remain the same because x is x here. So let me go ahead and fill those values in. Point A is -4 for the x value. Point B is -1 for my x value. And then point C is going to be 3. And what I did was I just took these points off of my image here. Now the y value, it says we had a y value and now we're going to have -y. So if my y value used to be 2, we're going to change it to a -2. So we should get a -2, and I'm going to go ahead and just fill these in and then check them. If I have a 5, I should have -5, and then 1 should be -1. And if I come over here and I look, my A prime, sure enough, is going to be 1, 2, away from my line of reflection, 1, 2, -2. And then we have same thing with my B. It went from a +5 to a -5, and then my C went from a +1 to a -1. And that is how I could count it. I could come over here and I could say, okay, when I draw my next image, I am right here and I am 1, 2 away. I'm going to go 1, 2, and that's going to be my A prime. And I can go 1, 2, 3, 4, 5 there. 1, 2, 3, 4, 5. There's my B prime. And then I can come over here and I can say C. I'm 1 away and I'm going to go 1. There's my C prime. Then I could connect the dots. I could do it graphically by, once it's mapped, but I could also come over here and use this mapping, right? Anytime we reflect over the x-axis, this is what we map to, x -y, and we can just do that conversion. Now, when we map over the y-axis, when we mapped over the x-axis, the x values didn't change. So when you map over the y values will remain the same. And our mapping is when we have here, we can go ahead and fill this in now, but it's going to map to, if we look, let's see, let's just do one real quick. And k, right here, the value of k, k is going to be point value, what, x is -1 and y is 3. So I have -1 and 3. And then my new k prime, what point do we have for k prime? Right here is going to be a +1 and a 3. Okay, so we have a +1 and a 3. 1 and 3. So let's see what happened when we did our mapping. 3, my y value used to be a 3. My new location, my y value is going to be a 3. So we went from y to y. My x value used to be a -1, and now it's a +1. So the sign changed on my transformation. So that is going to be -x. Because showing -x, that's saying that I had to reverse the sign. So that is my new mapping. This is my mapping right here. When I have reflection over the y-axis, it will be -xy will be my reflection. And we can go ahead and fill in the points. So again, I went ahead and just looked on my graph and came up with these point values, these xy coordinates for my points. And then my new points, I can come over here and I can look at them and I can label them, or I can look at my mapping. My mapping says that my y's will stay the same. Y is the same as y, so what I'll do is I'm just going to go ahead and fill those in. My y here is -2. My y here is 2. My y here is 3. Now, the mapping also says that my x values are going to become a -x. -x. So I had a -y, so it became a positive. Here I have a +y. It will become a negative. Here I have a -4. It will become a positive. And here I have a -2. It will become a positive. And you can double check these, but here are my mapping transformations. And if I just pick one, my new n value we said would be 2, 3. So n prime is 2, 3. Come over here, n, y value of 3, x value of 2. So yeah, that did work out. Okay, so now each one of these, we're coming up with specific mapping rules based on the reflection. And here we have a reflection across line y equals -x. So here's this imaginary line, y equals -x. And when we map, it tells us that when we reflect over y equals -x, our x and y values will map to -y, -x. So looking at this, it's saying that my new x value, because x goes right here, is going to be my old y value and opposite sign. So this value is going to be my y value with a negative, opposite sign. And we're going to look at it here to do a little bit of practice. But just knowing that, you know, that is telling us that my x and y coordinates are switched. They're switched, and they are both negated, right? We'll say negated, but they become the opposite sign multiplied by a negative, however you want to process that. Okay, so filling in my ordered pairs over here, I went ahead and just labeled my points on my graph, and I can come back and we can check these in a minute after we do our mapping. But if I come over here, let's see here, point A was going to be -4, -5. B, it looks like it is 1, -1. And then C looks like it is 1 and -5. Now, disregarding the graph, I'm just going to look at the mapping. And it tells me that it said they were going to be switched and they were going to be negated, which means to change the signs. So my new y placement, or my new x, right? This is the xy coordinate. as a reminder, right? This is going to be my xy coordinate. My new x is going to be the former y value with, negated, opposite sign. So my old y value was negative 5. So if we take negative 5 and we negate it, it becomes a positive 5. So that is going to be a positive 5. And then it tells us the new y value is going to be x negated. So my x value was negative 4. Negative 4 negated becomes a positive 4. Okay. Now let's look at the new a prime, and sure enough, a prime over here is going to be 0.54. Okay. Now I'm going to draw the negated in here on this next one when we look at point B. So, not B. We'll go to C first, because it turns out that B's point didn't change, so there's no change there, and I know that that is going to be 1, negative 1. But let's look at point C. Remember my new x value is going to be the former y with the negative. So my former y value was negative 5. So negative and then negative 5. So this was the y value and I negated it. And then the next one's going to be the x value negated. So that would be negative 1. And if I just go ahead and say C is going to be negative times a negative becomes a positive. So that would be 5 and then a negative 1. And if we come back over here and look, sure enough, C prime is 5, negative 1. So that's the math of doing the negated there. Okay. Now when we are talking about I guess we'll do an example here real quick. So we are reflecting, if you look, this is R prime, S prime, T prime, Q prime. Now that, or Q, R, S, T, that is the new image because we have prime there. That's the new image, and we are trying to figure out what the pre-image was, and we did reflect over y equals negative x. So now, in order to go backwards, what we can do is we can just make that same mapping in reverse. And I'm going to go ahead and put some points down here. Okay, so as we look at this, what I've done is I've gone ahead and drawn that mapping out, and I've filled in what we know, coming over here and looking at the image, and I filled in Q prime, R prime, S prime, T prime, and their points. Now, according to our mapping, when we make this mapping, the new image is going to be, for example, this is going to be the old y negated, this is going to be the old x negated. So when I look at this, this is this. So this used to be my y value, and I changed the sign, I negated it. So if I wanted to move this back to the y value and change the sign or negate it, this would become negative 2, because that's telling me that it used to be the y value. And then this used to be my x value, but with the opposite sign, so that would become negative 4. And if I just do the same thing, I have negative 4, which, and let's see here, I have right here, this would become what, negative 2, negative 4, and then I have what would appear to be negative 2, 2. And if you'll notice right here, that point is on the line of reflection, so T and T prime should be the same point. And if I go ahead and connect the points, we end up with this image right here, and we have, of course, S, R, Q, working backwards through our mapping. Moving on to another example here, and we're trying to figure out what in the heck. It asks us what rule is going on with this reflection. And if I look, I'm gonna pick a point, and I tell you what, let's go ahead and use point M. So M used to be, the pre-image was negative 5, 4, and then it mapped to M prime is now 5, 4. And what happened is, it looks like we had some kind of reflection over something for xy, and then it mapped to, it looks like my y didn't change, but my x changed sign. So that mapping would look something like this. Negative x, because my x value changed signs, and then y did not change. So what kind of reflection did we have? Well, we can also see too here that M is 5 points away from the line of reflection, and then M prime is 5 points away from the line of reflection, which makes my line of reflection the y-axis, and then if we recall my mapping on the reflecting over the y-axis, the y values did not change, but the x values did. So there you go, being able to come up with a mapping rule and being able to look at it on the graph. All right, so let's knock a couple of examples out here. Okay, so now that I got over here to the example, sorry I had to take a break for a moment. We have example number 4, and it says, what is the rule of reflection? And if we look here, let's just try to identify some stuff that's going on. It looks like A and A prime are going to be in the same location, and then D and D prime are going to be in the same location. So if those 2 points are in the same location, that means that my line of reflection passes through those 2 points. So it looks like my line of reflection is going to actually be the x-axis. Okay. Now, I could also turn around and say, well, it looks like that C is 2 points away, right? So we have C is 2, 3, and then C prime is going to be negative 2, 3, and I can see here that my y values did not change, and my x values changed sign. Okay, so looking here, sorry about that, I had to change because my little pointer wasn't working. So as we can see here, C is 2 points away from the line of reflection. C prime is 2 points away from the line of reflection. We also have the same going on with B, 2 points, and then B prime, 2 points. So it looks like my x values have not changed. However, my y values have become the opposites. So let's see if I were to write that. It looks like I reflected over the x-axis, and my xy values have mapped to, the x values didn't change, but my y values changed signs. And if I were to go back and look at that, I would probably see that that is my rule for the x-axis, right? The x-axis, that was the rule we came up with. But there we go. That's just looking at some of the characteristics that we could have identified by just looking at the image. As we come down here to B. As we come down here to number 5, consider the reflections of JKL. Okay, so we are starting with this triangle, JKL here. And what line of reflection maps point K to K prime? And it's saying K prime is going to be negative 5, 2. Well, let's see here. K prime is going to not be a positive 5, 2, but they're saying that it is going to be a negative 5, 2 is going to be K prime. Okay, and then we have what line of reflection? Well, it looks like I went from 5, 2 to negative 5, 2. Again, my y value did not change, but my x value was negated, right? So what would that be? My x value changed, so it looks like my line of reflection right here is going to be the y-axis. So the what line of reflection? Well, it looks like I'm reflecting over the y-axis. So we'll call it the y-axis. And then what line of reflection would give us point L to L prime? So they're saying L prime is going to be negative 2, 3. Okay, so 2, 3. Let's see here. If L prime is going to be negative 2, 1, 2, 1, 2, 3. Okay, so there is my new L prime. So it looks like we have xy maps to something, right? And my L used to be negative 3, 2, if you look here on the graph, and it maps to negative 2, 3. And if you'll notice, it looks like my x has become my y and negated. My y has become my x and it has negated, which means the sign has changed. So this is my mapping, and it turns out that I end up having a reflection over that imaginary line right there of y equals negative x. And sure enough, if we went back and looked, that would be the mapping rule for the reflection over y equals negative x. Let's see here, continuing on, we have a point P which is located here. If we reflected it across the x-axis to create P prime, in which coordinate is the P prime located? Well, let's see here, I have a reflection over the x-axis and my xy. And my mapping, we said, was going to be, I think, the x-axis. My x remained the same, but my y was negated. So if I have point P, and it is negative 4, negative 7, when I map it, P prime becomes negative 4, because my x would remain the same, but I would negate. I would have negative 7, which is actually P prime is going to be negative 4, 7, because a negative times a negative became a positive. And then we just think about where is, and I'm going to use this graph down here, negative 4, 7 would put me at negative 4 and a positive 7 right here, which is going to be quadrant number 2, because it is quadrant 1, 2, 3, 4. So quadrant 2 is going to be where that's located at. So quadrant 2. Okay, and then this last one, we were talking about figure ABCD was reflected across line y equals x to create A prime, B prime, C prime, and D prime. What are the coordinates of the pre-image of E prime? Okay, a lot of times when we get problems like this, I don't need to worry about the other points. They do not care, or they are not asking me about A, B, C, D. They're asking me about E. So if I'm just going to focus on E, which is right here, and that is going to be point, let's see, it looks like X is 6. So E prime is going to be 6, negative 2. Okay, so we had some point, and it says the y equals x, and I do believe the plan for that was the reflection over the line y equals x of x and y. The rule became yx. My x and y values switched. So if in this case, if I have, I'm looking for E, I'm looking for the pre-image, and then the E prime image is going to be 6, negative 2. Well, I just, look, this is my old x value, okay? So I'm just going to bring it over here, and my values change or switch. So this becomes negative 2, 6. So the original E transformation over this imaginary line of y equals x is going to be negative 2, 6, so that would be negative 2 and 6 right there. And sure enough, if you look, it does appear that this distance is the same as this distance. So there you have it. This was my original pre-image, sorry. So there's a couple of examples that we were able to walk through, and it may seem like a lot, but again, we're going to have these mapping rules available to us as we're doing our assignments. And the big thing is as we transfer back and forth between the rules, what they're actually telling us. So we will go ahead and continue with today's assignment.